Okay, I'd like to get started, please. All right, I'd like to get started. The bell is rung. Okay, so we are now kind of hopping around the book, okay, and we're going to go into Appendix F, okay, Appendix F, after I'm done. Okay, Appendix F. And so again, this is all really Algebra 2. You can be seated there. Where's the other spot? There are exactly 34 desks. No, Usman, I want him in here front. Yeah, because he's always on the text machine. Whereas I can trust you more than I can trust him. Okay, so we're going on to Appendix F1, and it's about graphing inequalities. So if you take a look here, I want to graph this inequality, okay, and here are your steps. Right? So first you graph the line, and I will put the x and y axis here. My scale, I'll graph the line, so when y is 0, x is equal to 4. Wow, stop it. Okay. When x is 0, y is negative 2. So here. And so I'm going to graph that line, and it says that if it is strict inequality like it is here, show it as dotted. Okay, show it as dotted. And then remember that these inequalities are all about shading a region. Okay, it's all about shading a region. And then it says use a test point. Okay. And a good test point to choose is the origin, unless the line goes through the origin. Okay, if the line's not going through the origin, 0, 0 is a good test point. So what you do is you put in 0 here, minus 2 times 0. Is that less than 4? Yes? Then that point is going to be in the shaded region, i.e. the shading is going to go like so. Right? Guys got that? Yeah. Do you understand how I expect this work to be done? Yes? Yes. Okay. Moving on, second example. So compound inequalities. In other words, there's more than one. There's more than one. Okay? So there's going to be some region of overlap, and there's a process for doing all that as well. And there's a process for doing that as well. So two inequalities, this one here and this one here. One's linear, the other one's quadratic. Okay? So we're going to do each one just like we did in the last example. So here's my x-axis, here's my y-axis, here's my scale. Okay, and then x minus 2y, that's the same as the last one, right? So when y was 0, x was equal to 4, and the other one was negative 2. And here's my dotted line. And I've already done the shading on this one, right, from the previous example. Okay, so in the previous example, I shaded it like that. And now what I need to do is I need to graph the quadratic. And in order to graph quadratics, it's probably better in this case to factor it. Okay, so you know what the x-intercepts are. X-intercepts are negative 1, negative 2. So it's going to go through there. Okay, it's greater than or equal to. So should that be dotted or solid? Solid. It's going to be solid. Is this quadratic opening down or opening up? Opening up. It's going to be solid, so it's looking something like this. you should really get this vertex down, okay? You should get the y value of the vertex because that's going to change the shading stuff. How do you get the y coordinate of the vertex? Well, don't you get the x coordinate? How do you get the x coordinate first? What's the x coordinate of the vertex in a quadratic? Anybody? It's the average of the two. That's one way, but does anybody remember the formula?
B over 2a.
Negative b over 2a. Negative b over 2a. So it's going to be in between negative 1 and negative 2. So that's negative 1.5. But what I want the y value because I don't know how deep this guy is going. Okay, so can someone chug on that? Put negative 1.5 in here and give me a y value, please. I'll pose the thing here. Sorry? Negative 0.25? Okay. Yes? So this is pretty reasonable there. Okay, it's pretty reasonable there. And now you're going to do the test point stuff. Okay, so pick the origin as a test point and put in the values for x and y. So is 0 greater than or equal to 0 plus 3 times 0 plus 2. Is it? Is 0 greater than 0 plus 3 plus 3 times 0 plus 2? No. So then the dotted part is not going to be in the shaded region. The origin is not going to be in the shaded region. So this shading is going to go like that. And then you want the overall shading where the two regions overlap. Okay, and you want to put that in some sort of a solid color. Okay, so I'm going to use my yellow, okay, my highlighter, and you can see that it is going to be in here. Is everybody okay on the process here? Yeah? Questions on that? Okay. One last example, and then I'll go and answer Josh's questions. Okay, linear compound inequalities. We're going to need this stuff, I think in the next section. I think it's either F2 or F3. So you really want to pay good attention there, okay? So the first thing you want to do is graph the lines, which I've already done. Okay, I've already graphed the lines. I would encourage you to use colors. First of all, it'll be very pleasing. You'll get a high from it because you'll be able to sniff the colors. Okay. 2, it looks pretty. And you guys know that pretty generates endorphins in your brain. And you get a high out of that. Okay. So it's all about getting highs. You know that. Life is all about getting highs. Okay. Sorry? From working out too. So I get my endorphins from 2 sources, okay? 3 sources. 1, working out, which I shall do today. 2, I'm going to club sport. You guys are going to come out. We can bench together. In that dirty gym there? Are you kidding me? I mean, I'll probably get, like you normally get athlete's foot. I'll probably get an athlete's head in there. Yeah, it's pretty ugly stuff there, man.
It smells delicious.
Oh, okay. Or I get it by playing Sudoku. Or thirdly, I get it by doing math.
Oh, dude.
Fifth Amendment, I shall not say any more because this is being recorded. So I'm not saying anything. All right, so you guys got the 3 lines down. Here's one of them. Okay, and I believe that corresponds to this guy. Okay, you might want to write down the equations next to those lines so I can see what they are and so you can see what they are. And then there's another one, x is greater than 2. Okay, x is greater than 2, so that's this one here. And then the third one is y is less than 2, so that's this one there. Okay, and you're going to shade for each one of them individually. Okay, shade for each one of them individually. So on the red one, we know it's going to be this one here, which comes from the previous examples. Okay, and then for the blue one, it's going to be greater than 2, so it's going to be out here. And for the black one, it's less than, so it's going to be out here. And where do you think the three overlap? The little triangle there. So look how pretty this looks. Isn't this fun? And I'm not even sniffing this stuff. So this is electronics. So all right. Right, and then we're going to need. So these guys here, the corners, these guys are called the vertices of the region, and we're going to need that concept when we do, I think, F2 or F3. Okay, one of those things. In a couple of days, we're going to need that concept. Okay. All right, you guys got graphing down? Okay. All right. Questions on homework, Josh? Yes. 38. What page number is that? 570.
Yeah.
570, number 38, did you say? Okay, let's go work on that. So number 38 on page 570. Okay? Everybody got their book open so that you know what's going on. People who have the sleeping disease, I know someone in Nairobi, Kenya, who's got an antidote for sleeping disease. You guys know the sleeping disease is transferred by tsetse flies. Is that how you say it? Tsetse flies. We used to call them tsetse flies back in the, not sexy. Okay, it's spelled TSE, TSE. Tsetse flies. Okay, that's how sleeping disease gets transferred. Okay.
That's real?
Sleeping disease is where if you get bit by that fly, you shall sleep forever. And not like he's in dead, like not as a dead person, but seriously sleeping. You can wake up, you take a snack, and then you go back to sleep. Yeah, it's fun life. I mean, it's like, it's like what the math students, some math students do in my class. They come in here, they get a whiff of the colors and the highs, and then they go. And we got two prime examples there. Okay, two prime examples. Okay. Yeah, I know. That's why I let sleeping dog. Oops, I was going to say that, but never mind. You know what I was going to say? Let sleeping dogs lie. Ah, get it?
Oh, this is being recorded.
Oh!
It's over.
Okay, number 38. So Josh is asking me this question because he's going to be one of those people on Whore Street. You guys know that I call Wall Street Whore Street? Whore Street is not, yeah. Yes, WHORE, not TE.
I said E.
E is equal to Wall Street.
4th Street?
4th Street. Okay, here's the analogy. Okay, what do people on Wall Street do? What is their main motivation in life?
Take your money.
What's the main motivation for a whore?
Take your money.
Hello? Is that an equation or what? Is that an equation or what? You're kind of slow, man. I just said A equals B, then I said C equals A, therefore B equals C.
Well, okay, you did it like that.
I made it very explicit. Okay, all right, number 38. Number 38. A total of $46,000 is invested in two corporate bonds that pay 6.75 and 7.25 in simple interest. The investor wants an annual interest income of $32.45. What is the most that can be invested in the 6.75 bond? Okay, so this is the way you start. Let X dollars be in 6.75. Let Y dollars be in 7.25. Okay, so these statements are necessary. They are required. Okay, because it's setting the problem up. Okay. And the total amount of money that he's investing is $46,000. So, do you buy this, Josh? Question 1. Then the interest that he gets out of the X is going to be 6.75 over 100 because that's the percent. Okay, that's the amount of dollars he's going to get out of the X amount. You with me on that? Right? And then out of the Y, how much is he going to get, Josh? 7.25 over 100 times Y. And how much does he expect total? 3245. You have two equations with two variables. You know how to solve that? My suggestion to you would be to use substitution. Okay, would be to use substitution. All right? You guys all right on this stuff? You okay on how to set it up? And solving is the trivial part. Would you agree? Amy, would you agree? Okay, are we done then? Are we done? Okay. Again, at about 1:15, 1:20, I need to rearrange my the desks, okay, for next period, okay? Today is the last final, yes.
How many questions do they have?
Yesterday they had 9. Today they have